This is section 7, chain rule, example 4. So sometimes you don't just have x and y in your formulas, right? You actually have a's, r's, v's, s's, right? C's, d's. So when that happens, all of your variables are going to be not with respect to each other, but they're going to be with respect to time. So that means that when you find the rate of change, because remember, finding a derivative is finding a rate of change, you have to keep in mind that the variables are functions. Every variable is a function because that rate is going to change. So, for instance, right, when I find the derivative of a here in part A, and I move that 2 to the front, r is a function. R is a function. A is a function and R is a function. And so I'm going to write it a little bit differently. It's going to look a little bit different from what I've been writing. I'm not just going to write A prime. I'm going to write dA dt. Okay, when I take the derivative. And what that means is that I'm taking the derivative of A as a function with respect to time, which is what it tells me to do, right? It says with respect to time. So I have to keep in mind that A is a function of time and R is a function of time. So as time changes, the area will change and the radius will change, both of them. A is dependent on R, but they both rely on time. So now I'm going to keep going, right? I'm still going to take the 2, move it to the front. Remember, pi is a number, so I don't have to worry about the chain rule. Sorry, not the chain rule, the product rule. So we have 2 pi r, because that exponent's going to go down by 1, times the derivative of r, because technically r is my inside function. I didn't touch it, but I do have to multiply it by the derivative of that function, which is just dr dt. And again, I have to do that because r is a function and a is a function. Let's show you b. To find dv dt, s is my inside function. I'm going to take that 3, and then I'm going to get s squared, right, just like always. But I can't forget to multiply by the rate of change of s. It's very important, very, very important. Okay, for c, dv dt, if I take that 3 and move it to the front, 3 times 1/3 is 1. So it's just 4 pi r squared times the derivative of the function, r. And the derivative of r is dr dt. You can technically write r prime, but it's going to help us out in the future to have it in terms of t. Okay, to have that t there. It's going to make a lot more sense when we get there. And then here, dc dt is going to equal pi. Now the derivative of a number times a function is just the number, right? It's just that coefficient. And remember, pi is a number. We're not actually using the product rule here. But d is a function of time. So even though the d disappears, right, because you're just it just becomes 1, you still have to write, oh, interesting, the change of the diameter in terms of time. That's it.